radius. Distance formula, as you all know, y2 minus y1 squared plus x2 minus x1 squared. y2 is 4 minus 3 squared plus 2 minus negative 1 squared. Chun-Li?
But how do we know if the point is on the outline of the circle or on the inside?
Doesn't it say that it passes through? Yeah, passes through the point. So that's how we know it's on the actual circle. Good question. So like anytime they say it's on the circle, like that also means that it passes through that point. Yeah, right. So like, I mean, if it says, if like here's a circle and it passes through, the point has to be here or here. If you have a point inside here, like that's not like passing through. That's like surrounding, maybe would be the word they would use for the brown point. But the purple one would be like pass through. Does that make sense, Chun-Li? Chepe? Cool. So square root 4 minus 3 is 1 squared. 2 minus negative 1 is 3 squared. So 1 plus 9. So square root of 10 is the radius, but we want r squared, so we're just going to put in 10. We're just going to put in 10. So our equation would be x minus 2 squared plus y minus 4 squared equals 10. Now there's another way to get the radius. It might actually for some people be considered a bit easier, and that is to do the following. So this was one way. Not that this way is wrong at all. In fact, I think this is probably the more conceptual way. But another way is just taking, so here's the equation we had, x minus 2 squared plus y minus 4 squared equals r squared, and just plug in the point negative 1 comma 3 into the equation and solve for r. Because if the circle goes through the point negative 1, 3, that has to satisfy the circle. You just put in negative 1, 3. And there you see that r squared is 10, which is what we got before. Either method is totally fine. Depends on which way you like more. Does not matter at all. Questions on that? Okay. So the next thing we want to talk about are ellipses. So ellipse is the next type of conic. This is the second one. We're going to do 4. Not all today. So there are two types of ellipses. The first is a horizontal ellipse. So a horizontal ellipse, by the way, ellipse is just a fancy word for oval. So here's a horizontal ellipse. And I want to do some analysis on this horizontally, and then we'll do a vertical one after that. We'll start horizontal. Every horizontal ellipse, every single one, horizontal because it's bigger horizontally than vertically. Every horizontal ellipse has this equation. X minus h squared over a squared plus y minus k squared over b squared. Every single ellipse has this equation that is horizontal. And now we'll just go through some of the key features of an ellipse. Chun-Li? Question. So we'll go through some characteristics of an ellipse now. So start us off. So what I'll do is I will draw in the characteristic here and then provide like a glossary definition on this sheet. So the first one is center. So every ellipse has a center. And the coordinates, just like a circle, are h comma k. Exactly like a circle. The next thing is every ellipse has what we call a major radius. Major radius, which is the distance from the center, distance from the center to we call this a vertex. Put that in a different color. So this point right here is a vertex. There are two, don't say vertexes, say vertices. There are two vertices, one on each end. The major radius is represented by a in the equation. So you know how we got this a squared here? Well, a is the major radius. So let's look at vertex. Vertex is the end point of the major axis. So the major axis is this whole distance. Like a diameter on a circle, it's this whole thing from one vertex to the other. We call that the major axis. Major axis. It's the longer axis. We have a minor one, which I'll get to in a second. Longer axis, and it is the distance between the vertices. And it is represented by 2a. So if a was the major radius, we double that to get the major axis. Okay. Now we have the minor radius, which is right here, that yellow, just from the center up. We have the minor. Here comes another email. I'm wrong. Minor radius, which is the distance. And let me move this up. Distance from the center to a new vocab word here, covertex. These are called the covertices. And notice that the colors are matching up with what we're doing here. And the minor radius is represented by B. Minor radius represented by B. We have a covertex, which is the end point of the new vocab word, minor axis. And minor axis is this distance right here. This is called the minor axis. The minor axis. So now the minor axis is the shorter axis, and its distance between the co-vertices, and it's represented by 2 times b. Then we have the foci. These are 2 points on the major axis, so somewhere like here and there. And we have a formula. C equals a squared minus b squared, where c is the distance from the center to the foci. Now, let me now draw a picture of a vertical ellipse. Definitions are all the same, just one slight difference. Let's go ahead and do that now. So on the vertical ellipse, okay, here's our vertical ellipse. So we start with the center. Then we have the major radius. There's major radius. This time the major radius is up and down, because it is a vertical ellipse. It's stretched tallways. Then we have our 2 vertices. Then we have our major axis. This time the major axis is up and down because we have a vertical, not horizontal ellipse. Then we have our minor radius. We have our co-vertices. And then, of course, we have our minor axis. And then the final piece we have are the foci. Somewhere down here, 1. Somewhere up here, the 2nd. Questions on that? So then we'll apply this with some problems. The general equation for a